January 2014, question 5. When dealing with trig parametric equations, we have cot and we have sine. We need to think of the trig identities. So we have sine squared plus cos squared equals 1. We have that tan squared plus 1 equals sec squared, and we have that cot squared plus 1 equals cosec squared. Important thing to note in here is that cosec is 1 over sine. So if we take our two equations at the top, and we have that cot theta equals x over 2, sine theta equals 3 minus y, then cosec theta would be 1 over 3 minus y. Now, starting from that then, we are saying that cot squared plus 1 equals cosec squared. Curve crosses the y-axis when x equals 0, and we can then substitute that in. So 1 equals 1 over 3 minus y all squared. That means that 3 minus y all squared has to equal 1. And we have two solutions. 3 minus y equals plus 1. So y would equal 2. Or 3 minus y equals minus 1. In which case y would equal 4. So our solutions are 0, 2 and 0, 4. If we want to differentiate this, we have a quotient. So the top line is u, and the bottom line, the denominator, is v. So u is ln x minus 1, and whenever we differentiate that, we get 1 over x. V is 3x squared, and whenever we differentiate that, we get 6x. Quotient rule says the differential of y is v du dx minus u dv dx all over v squared. So that is 3x squared times 1 over x minus ln x minus 1 times 6x all over 9x to the power 4. We need to start working on simplifying this. And the first thing I can say is everything has an x term. So I have an x, and an x. Then on the top line, I have 3x times 1 over x, so those x's will cancel. So I now have 3 minus 6 ln x minus 1 all over 9x cubed. I can also see a 3 in every term. 1, 2, and 3. Still have some simplifying to do. On the top line, I'm going to have 1 minus 2 times minus 1. So that is 1 plus 2, which is going to be 3. Take away 2 ln x all over 3x cubed. Now you can do those simplifications at different stages, but you should still end up with the same answer. Part 2, we're then asked to integrate. First thing we'll do is expand the brackets, and when we have a square, we square the first term. We then have the product times 2 of the terms, and we square the last term. So my denominator becomes e to the power 4x minus 2e to the power x plus e to the power minus 2x. And I'm going to write e to the x over each of those. So I'm integrating e to the power 3x minus 2 plus e to the power minus 3x. If I integrate e to the power 3x, I get 1/3 e to the power 3x. If I integrate minus 2, we get minus 2x. And if I integrate e to the minus 3x, we get minus 1/3 e to the minus 3x. And never forgetting the constant of integration.